Hi there, Colin Gwynn here with DJI, and in this video we're going to do a more in-depth walkthrough of the Wookong Assistant software. We're going to go screen by screen and just kind of give you a look at the different settings. Now, I have this master controller for my Wookong set up with an S800 and carrying a ZenMuse, of course, like I'm sure most of you guys out there have. So let's take a look. The first screen is mounting. Our IMU orientation, you just simply tell it if it's forward, back, left, or right using the arrow on the IMU. For the S800, of course, we have forward. This is our center of gravity location, you know, our reference from the center of gravity of the complete aircraft. Our GPS is at -22 on the Z-axis, which means that it's about up here where our gimbal and everything is down here. So we're about 22 centimeters above the center of mass of the complete system. That's because we're using the tall GPS pole. So all you have to do is basically measure out your locations here. So that's as a matter of just following the manual. Motor mixing for the S800, we are a Hexarotor 5. As you can see, as you scroll over each of these standard configurations for multirotors on the market, most configurations are included here automatically. If you need to customize, you can. That's explained in more depth in the manual. But most of you will find one of these 9 standard configurations fits the multirotor that you're using. The next screen is transmitter calibration. As you can see, as I move my sticks on my transmitter, you can see that everything is being displayed on the screen. So to calibrate, you simply hit start here, move around your sticks to their full extremes, and then hit stop. Pretty simple. To check if your reversing and normal is correct, you can take both sticks and go up and to the right. If you put both sticks up and to the right, then everything should move up and to the right. Everything should move here to the right side of the screen. So that's kind of a quick way to make sure that that's correct. Your receiver type here is traditional, pulse width modulation, DBUS, or PPM. So I'm excited to say now that a couple of days ago we have the new firmware that allows for the new 7008 SB receivers that go with the 18MZ. The S-Bus on there should start working. Has a DBUS channel here. You pick your cutoff type between intelligent and IMM, which is explained down here what the difference is between the two. Also in your manual, of course. So I use the intelligent cutoff type. And down here you can monitor your stick movement. So I have one of these extra channels set up for a remote gain, and the other extra channel I have set up to do intelligent orientation control. So you can see that there. Down here you've got your manual attitude or GPS attitude. You'll need to set up the fail-safe position on your transmitter to land in one of these fail-safe zones when you turn off your transmitter. So that's set up in your transmitter. So if you turn off your transmitter, you pop into the fail-safe here to confirm that. The next screen is Autopilot, and as you see, I'm adjusting my pitch and roll gains for the Autopilot on a knob. So if it starts getting really windy, I can turn up my gains a little bit. If it's nice and calm, I can have my gains a little lower. The attitude gains here is just kind of how quickly the craft will respond to movements on your stick. So we use widely varying gains depending on the conditions. Sometimes our vertical is 165, sometimes it's 210, sometimes it's 195. It's something that you just need to work with and try different settings and different conditions. There's not really any set gain settings that's going to be correct in all situations with all payloads. The advanced parameters you really don't need to worry about. If you have a very customized project, you can read into the advanced parameters a little bit more. It's basically talking about the air density, and it gets into some pretty complex systems that for multirotors that are more customized or maybe really heavy lift applications can get into the advanced parameters there. You have an enhanced fail-safe methods, either to go home, to hover, or to go home at a certain altitude. If you say go home, it's going to automatically go home from 20 meters above where the reference altitude is, which is when it got its home lock position, which should be on the ground right before you take off. So it should be going up to 20 meters to come home. You can select your X3 channel to be a go home switch. I use my X3 channel as a gain channel. And then for intelligent orientation control, you can see I have that set up on its own stick. So I can go to course lock or to home lock. You can set up, you can change this to go to course lock and point of interest mode, depending on what you're shooting. And that's up to you, which way, which two of those you want to be available to you. So that's your intelligent orientation control. Gimbal settings, if you're using a ZenMuse, you will not be using this screen. If you're using another gimbal on the market, then you can turn on 2-axis control of your gimbal right here. You can set your servo travel limits, your output frequency. You can do your gains. So this is all explained in the manual, but you basically want to do it so that as you roll or pitch the craft, the camera stays level. You can control the speed of the pitch axis when you're actually controlling it, so you can make it operate very, very slowly or quickly, depending on what type of servo and what type of potentiometer and what your drive ratio is for any given gimbal on the market. So this is kind of your screen to be able to adjust your gimbal settings. Finally, we have our voltage monitor, which is your way of basically adjusting your low voltage protection. So I have my protection turned on. I'm telling it I'm using a 6S LiPo, which any S800 user out there should be using a 6S LiPo. Tells you my current voltage right now, which is not a fully charged battery, is 24.3 volts. I have my first level protection set at 22.8 with 1 volt of loss. So at 21.8, I start getting a flash green light, fast flashing green light. And then at 20 volts, it's going to start landing itself because we're very close at that point to running out of batteries and crashing anyways. So that's our quick look at our voltage monitor. And that's kind of the quick look at your settings and the different screens of the Wookong-M Assistant. So in the next video, we're going to take a look at the actual test flight and the LED light patterns in the master controller and in the Wookong, so that it can tell us what mode we're in and how many satellites we have and things like that. So see you guys then.